Initiating System 1. System 1 loaded.
The gas mileage of an automobile is affected by many factors like road surface, tire type, velocity, fuel octane rating and the speed and direction of the wind. Explain how the use of derivative of the velocity effect on the gas mileage. Good luck to all members.
According to Collins Dictionary, gas mileage can be defined as the ratio of the number of miles traveled to the number of gasoline burned. Fuel efficiency. Attaining good gas mileage means that you consume less gas for a large distance per mile. Gas mileage is measured in mpg. There are many factors which can affect the gas mileage. Velocity is one of it. For example, if a car travels at a high velocity, the more fuel will be burned. Hence, the higher the velocity, the higher the fuel consumption of the car.
This is the example of a problem about gas mileage. An automobile's gas mileage is a function of many variables. If we look at velocity's effect on gas mileage, the mileage of a certain car can be approximated by mv equals to 0.00015 v cubed minus 0.032 v squared plus 1.8 v plus 1.7, where v is the velocity. A car is traveling at the function of st equals to 3t squared plus 15 tons. Given v equals ds over dt, determine the velocity in miles per hour after 3 hours of traveling. Then determine the gas mileage when mv equals 0.00015 v cubed minus 0.032 v squared plus 1.8 v plus 1.7. V is equal to differentiation of st, so just differentiate the equation using power rule and we got 9 tons plus 15. After differentiate the st equations, the car is traveling for 3 hours, thus we replaced all the time, t, in the equation as 3. After solving the equation we got 42 miles per hour. And finally, we need to insert the previous velocity into the mileage formula, replacing the v with the newfound velocity. And the final answer for the mileage is 31.97 miles per gallon.
Fuel efficiency varies with speed. Aerodynamic drag increases proportional to the speed squared. There is rolling resistance from the tires, and transmission losses. The internal combustion engine is more efficient at different engine speeds, and cars have gearboxes to convert the torque generated by the engine to drive the wheels at appropriate speeds for the conditions. Drive a car too slow, and in a lower gear you're wasting the efficiency of the engine, and the fixed parasitic costs associated with the car's mechanical systems rob your efficiency. Drive a car too fast and you're burning additional energy for the luxury of pushing through the air at a faster speed. But at what costs? Have you ever wondered about the miles per gallon per mile per hour curve? Obviously, every make of car has different profile curves, but here is some data based on average information. graphed out, with speed on the x-axis and fuel efficiency on the y-axis. We can see how, in this case, the highest efficiency of the vehicle is obtained around 50 to 55 miles per hour if you are going to drive at one particular fixed speed to maximize your range. Then, in this particular car, it would be most advantageous to travel at a speed of 50 to 55 miles per hour. We're ignoring here any effect of gradient or wind. When we travel faster we cover distance in a shorter time, but this comes at the penalty of higher fuel consumption.
So basically, fuel consumption is affected by this major variable, which is the velocity of the vehicle. Hence, we can conclude that increasing in velocity will increase the fuel consumption or vice versa. In the conclusion, there are many factors that can affect the gas mileage of a vehicle. When the vehicle changes its velocity or accelerate, the more fuel will needed, and the consumption of the gas also will increase. Therefore, the driver must manage the speed of the car, then accelerate in order to reduce the consumption.